Alright, this video is going to look at numbers 19 through 21. And before we get started, this is all solving. We have to understand that exponential functions are the inverses of log functions. So in order for you to get rid of a log like you have in maybe number 19 and 20, you have to use exponents at some point. Okay? And it's to get rid of bases of exponents like this 3 and this 27, you might have to use logs. So I wanted to take a look at this chart that we've had on the board for a while. This is something that you want to memorize and then also write down on your paper once you get your test. Okay, so these are the 4 types of questions you're going to have. You might have on one side an exponent and on the other side you have an exponent. Or you might have a log on one side as well as the other. If these either of these come up, what you want to do is get the bases to be the same, and then you can just cross them out and focus on either the exponents or the arguments in the log. Okay, so an example of this would actually be number 19. So notice, I have a log on one side, a log on the other. So since their bases are already the same, they're both 2, I can actually just cross them out and focus on the arguments. So I have 3x minus 1 is equal to 2x plus 2. And now it's just an Algebra 1 problem. I'm just going to go ahead and get all the x's on one side, constants on the other. So I'll subtract 2x, add 1, and that just equals 3. What I want to do now is actually double check on my calculator. Okay, so the left side has to equal the right side when you check on your calculator. So I'm going to go ahead and put in log base 2. So I'm going to use math, option A. Log base 2 of 3, instead of 3x minus 1, I'm going to say 3 times 3 minus 1. That equals 3 on the left. Now I hope when I type this in, it also equals 3. So I'm going to go math, option A, base 2 of 2 times 3 plus 2. So the left is equal to the right, so I know my answer of x equals 3 is correct. Alright, for number 20, I also see something that's a little bit different. I don't have a log on the right side, I only have a log on the left. So let's go back to our chart. Alright, so what I have here, I have the bottom case. A log is equal to a number. Okay, so when a log is equal to a number, we're going to exponentiate each side. That doesn't mean I'm going to have to use an exponent. That means I actually have to change these into the exponent. So the only way I can get rid of this log base 3, because that's not what I want. I want to get this by itself. I have to go ahead and actually use a base 3 for my exponent, and these, the original problem actually becomes an exponent, so 3 to the 4th. If they're right next to each other, I can go ahead and cancel them out. See how 3 is the base of my exponent, 3 is the base of my log, they're the same, they're right next to each other, I'm going to go ahead and cancel them out. All I'm left with is x minus 1. 3 to the 4th is equal to 81. I'm going to add 1. X is equal to 82. Alright, remember to double check your work. Okay, remember another way you could do this is if you store a number. So I'm going to go ahead and put 82 stored as x. And instead of using, math option A, remember you can use your change of base. So I'm going to put log of x minus 1 divided by log of 3. Hopefully when I hit enter it equals 4. And it does, so I know I have the right answer. Okay, so I would use this change of base if I only had a TI-83. Okay. Alright, the next one. We have 3 raised to the x minus 7 power equals 27 raised to 2x. I know 3 is a prime number, 27 isn't. And I'm wondering, well, how can I get this? How can I go ahead and solve this? Well, we have an exponent equals an exponent. Very similar to number 19. I can cross them out as long as I can get these bases, 3 and 27, to be equal to each other. Alright, so just going back to the chart. get the bases to be the same, then cross them out. Well, 27, I know, is 9 and 3, 3 and 3. So it's actually 3 to the third power. So I'm going to rewrite this problem to be, instead of 27, 3 to the third power. And since 3 is equal to 3, we just go ahead and cross them out. What I have left is this x minus 7 is equal to 3 times 2x, so that's 6x. Okay, so I'm going to get all the x's on one side by subtracting x over here. It's 5x, I'll divide by 5. X is equal to negative 7/5. So let me double check my work by plugging this in. So I'm going to store negative 7/5 as x. Left side, it's 3 raised to the x minus 7 power, so 3 raised to the x minus 7 power equals that number. The right side, 27 raised to the 2x power, 27 raised to the 2x power. These numbers both match, so I'm good to go.